this section is going to add some more vocabulary, but it's going to be math vocabulary. So there's always going to be a bunch of caveats and careful wording of everything here. So I'm going to try to go through this as slowly as I can because these are more math concepts than anything else. So the first thing we need to be concerned with is what's called an experiment. This is very different than what you may have thought of as an experiment in science class, where it's like going into a lab and like doing something. An experiment is just going to be anything that gives us data. If I flip a coin, that's an experiment, and because I can record whether it's heads or tails. If I roll a die, that's an experiment because I will get something 1 through 6. If I ask somebody what their hair color is, I will get some data from that. So anything that generates data that's useful for us, right? Like if I'm trying to get heads or tails and I roll a die, obviously that's not useful. But just anything that generates data for something we're trying to record data about is an experiment. Okay, so I list some things here. Rolling a die. If I randomly assign some cancer patients to get chemo and some to get a placebo and record whether they're go into remission or not, in other words, whether their symptoms improve or not, then that would be absolutely generating data, right? Whether they're in remission or not, and then what group they belong to. All that's generating data. Asking classmates what their favorite subject is in college, that is generating data. So all of those are experiments as far as we're concerned in probability. All right, let's talk about this outcome and sample space. So the outcome is the actual thing that happens. So flipping a coin would be an experiment, and then if I flip a coin and get heads, that heads is the outcome, okay, of that experiment. So the actual like piece of data that I get is the outcome. And a sample space is the set of all possible outcomes. So I feel like that's fairly straightforward except for this word set, which is where I got to talk about things a little bit. So sample space is, just think of it as everything that could possibly happen. We just have to make sure it's a set. Okay, so a set is a list of stuff. And I'm not jokingly using the word stuff here. It's literally some stuff. It doesn't matter if it's numbers, right? In statistics, we very often will record what's called categorical data, which would be, like what country you were born in, right? That's not a number, but it can be useful demographic data. So it can be any kind of stuff. It doesn't even have to be the same kind of stuff. I'll get to that in just a second. So the stuff can be listed in any order and still be the same stuff. So in other words, if I have a list that says heads and tails, and I've got another list that says tails and heads, right? So they're in a different order, but it's the same stuff. Those are the same set of stuff, okay? So a common way of thinking about this set idea for me is a grocery list. Okay, so it doesn't matter the order that I've listed things in a grocery list. If it's the same stuff on there, it's the same grocery list. All right, and the number 2 thing is the list can't have the same thing twice. Well, same idea then with this grocery list, right? If I've got milk, eggs, cheese, milk, like why did I list milk twice? Like I just needed the milk, right? So I don't want anything listed more than once, and the order in which I list things doesn't matter. It all ends up being the same then. Okay, so let me go through these things here and identify whether they're sets or not. Okay, so the first thing that we'll notice about these first 2 things is they both have 0, 1, 2, 3, but one has parentheses, this first one, and the next one has what's called curly brackets or curly braces. These curly braces are what we use for sets, and that's because these parentheses actually have an extra thing that you may or may not have ever been forced to learn in math classes, but that you maybe kind of picked up anyway, right? So you've all seen, little axes like this. You've all at some point had to plot, let's say 1, 2, right? So my x, that's my y. So 1, 2 would be 1 over and 2 up. That's right there. What about 2, 1? Okay, well that's 1, 2, that's over here. That's a different thing. This and this are different things. And you may or may not have ever been taught this, but the parentheses actually tell us that it's ordered. The order matters, okay? So that's how this is different, is that the order matters, and I would be allowed to have something like this, right? 1, 1. Well, I've got the same thing listed twice there, but it doesn't matter because it's for different variables. Okay, so the order matters here. This is a completely different thing. Okay, so this is an ordered pair is what that would be, because there's a pair of things. But in any case, this is not the symbol that we use for sets. For sets, we use those curly braces, and the first time you write them, you'll probably do something like this. And, you know, it's okay, but it kind of just looks like a squiggle. If you want them to look clear so that you can read them for yourself or for me when you're turning in a project or something like that, just separate it into two things. Doesn't that look nice? All I had to do was separate it into two pieces, right? A top and a bottom part of your curly brace, and now it looks nice. So anyway, that's not math, but that's a nice way to write things in case you ever need to write these out. Okay? So this first one, no, it's not a set. It's an ordered quadruple. Whatever. It's an ordered thing, so that's not what we want. What about this next one? Okay, well, I'm inside the curly braces, so that means the order doesn't matter. And I don't have anything listed more than once, and it's a list of stuff, right? It doesn't really matter. It happens to be numbers here, but it doesn't really matter. I don't have anything listed more than once. That's a set. This third one, 3, 1, 2, 0, is inside the curly braces again. Okay, so that's good. I don't have anything listed more than once. The only reason I have this listed again is that I want you to realize that this 0, 1, 2, 3 and this 3, 1, 2, 0 are the same set because they have the same stuff in it. So it does not matter at all what the order that we've listed things in is. It just matters, does it have the same stuff in it? In which case, it is the same set. Okay, so these are both sets. The second and third thing are both sets. And they are what's called equivalent sets because they have the same stuff in them. All right, PlayStation 4, Xbox One, Nintendo Switch. I didn't list anything more than once. It's got stuff in it. Okay, that's all that matters. It can be any kind of stuff. Doesn't matter what it is. Doesn't have to be numbers. Doesn't have to be anything even intelligible. All right, so I've got a meh face here, a sad face, a happy face, and then another meh face. Well, I've got that meh face listed twice here. That is not a set. I can't work with that in the way that I want to. And we'll get to that as soon as we get to probabilities, because this makes it look like there's 4 things there when there's really only 3 things. And the size of sets is going to be very important to us in probability. All right. What about 5 sad face Claudia? Well, I've got a number. I've got an emoticon or whatever, an emoji here, and I've got someone's name, right? These are completely unrelated things, but remember, it just has to be stuff. They don't have to be the same kind of stuff. It's just a list of some stuff. Okay, I didn't list anything more than once, so yes, this is actually a set. Okay, so getting back to the actual point here, the point was not what a set is, it's that a sample space is a special kind of set that lists out all the possible outcomes of an experiment.